that is cost reduction factors, what to be considered for a photovoltaic system. So that will take in the last part here and we'll complete the topic. So coming to this photovoltaics cost reduction factors, we can think on different ideas here. Also, you can also give some ideas for me or to others so that you can have better understanding how to reduce this cost or how to reduce the different losses in the solar PV systems. The first thing is to support the innovative or innovation in the solar devices or the solar cells and development of new improved techniques to produce the solar cells. So for this nowadays thin film technology, or you can also see the different wafer formation technologies are coming up in mass production. So this mass production will help us to reduce the cost. So that's the second point I have written as increase the production volume. That is the mass production of these PV systems or the PV cells. So by this one of the method, we can generate the PV systems or the PV cells at very low cost. Also, the government is also taking many initiatives from last decade to improve its mass production and implement the solar plants. So wherever the possibility is there, the solar plants can be planted and the free energy can be converted into useful energy. Also, reducing the wastage of the materials. So as in the yesterday's videos you have seen, the wastage of the material is more in monocrystalline silicons, where we have to prepare the casting in proper sizes. And later we are going to cut that into number of slices in wafer form or the very thin sheets. So in these processes, the loss may be very high. But latest technologies, if you observe, okay, so in that we are going to just take the material and we are going to print it on the uh, glass layers as a thin film structures, and it can be folded. It can be folded and carried anywhere. So in such technologies, the material wastage is very less in the printing technologies. So such type of methods can be utilized to reduce the cost, but sometimes efficiency is lowered. Efficiency may be less, not an issue, but anyhow, the material wastage is also reduced. Say for example, other solar PV cells, if you see, the gallium arsenide, as I told, the material is available very less in the nature. Also some other gallium or telluride, if you see, or the selenide, if you see, such very costly materials, if you are working with, then you have to reduce this material wastage. Then if you are using the PV systems, the efficiency can be also improved by going for the concentrators or the mirrors, or other than concentrators, as yesterday I have shown you, the smooth surface of the PV cell can be made in a zigzag form or in a pyramid shape so that multiple reflections can happen on the surface itself. So it can absorb the more solar light. Here we are concentrating more on the light, not on the heat energy of the sun. So for that purpose, we can make the rough surface such that it may act like a Fresnel lens, or it may act like a multi-reflector surface to absorb the maximum solar radiations with light. So more photons can flow to the PV system. Okay. Any disturbance in network? Any audio video disturbance is there?
No, sir.
Okay. So that using the solar concentrator is one of the method. And even in other than multicrystalline surfaces, the monocrystalline surfaces, if you see, those are maximum times they are very smooth. Or even with the pyramid or the rough surface of the PV cell, I can also use some extra collectors which can reflect all its solar light towards the PV cell so that it can focus more light and it can generate more electricity, so that by which we can increase some efficiency of the PV cell. So this is one of the method. So this will reduce the cost by not adding the extra cells. So by reducing the number of cells and just by increasing the number of concentrators, one can go for reducing the cost. And the latest information, if you see, the solar power in the present total installed capacity in India is around 35 gigawatts as per 2020 data. If you consider, it is 35 gigawatts, and India is also producing the extra power, and it can also transfer it in any given different countries and other things. So extra power is also generated from this PV cells. That is one of the advantage, and the price is around from this PV systems per unit. If you see the price in India, it is the lowest compared to all over the world. India is taking rupees 2.62, okay, 2.5 rupees per unit of energy from the solar PV systems. So 1 unit is nothing but 1 kWh. So for 1 unit, India is the lowest claiming the price for the PV cells. That is only 2.62 per unit. And lowest price of the panels per watt. So wattage of the power is this panels, if you see, or the modules, if you see, per watt, the lowest price is up to today is around only rupees 35 rupees. So as per the wattage required for any house or any buildings or the industries, if you see, as per that wattage, we can calculate for the required amount and required power. We can go by purchasing the PV cells locally. So per watt, the price is up to only 35 rupees, and per unit price is 2.62. That's the mass production, or from the solar plants. If you are getting the power, the government is taking only 2.62 per unit from the solar systems, because running cost, maintenance cost of such plants, and also the using the raw materials for any thermal plant or the power plant is very less here, almost negligible. So because of which, what will happen? Only they are taking the running cost or the cost required for taking the payback, or within that payback period. Until that, the cost may be high. Once the payback period is reached, or once the money which is spent over the plants or the solar plants, once that money is reached, they can stop taking the extra money also. So there also we can increase, or decrease the cost of power after getting the payback period. Next point is, we discussed about the standalone system, grid connected system, or the hybrid system. So recalling those three systems, in this discussion we can see the solar plant owner, okay, with the grid connector system, the grid connected PV system, where he can supply the extra power to the grid or to the public or the government, and any little amount of power is required, he can utilize for the home. And it may also depends on the season. So in some seasons we cannot run the solar system or solar power plant, but we can get the power from the thermal power plants. So like this, we can have the agreement with the government or some commercial industries. So in such conditions, the solar plant owner would receive nearly the double price. So as of present, we can go for the PV system. Initially, he may have to invest more money, but after some that time, he may get almost double the price of electricity sent into the grid. Okay, so double the price of electricity sent to the grid compared to that consumed from the grid. Means he can send the power to the grid other than using the power from the grid. So that will be the advantage in given proper seasons like summer or winter. He can generate more power, and whenever in the rainy season or cloudy season, he can take the power from the grid. So that is net metering he can do. Okay, so this all depends on the based on frequency of use and tariff offered by the governments. Okay, so that all depends on the season also. The last thing is using, we can reduce the cost of PV cells by using it in wastelands or the large building areas. Or latest news what I understood is the Scania, what is the truck builders are there. They are planning to make a complete container of the truck with solar PV panels on the surface. And whenever the truck is traveling, it will absorb all the solar energy in the electrical form and it will store in the batteries. And whenever the vehicle is parked, okay, whenever the vehicle is parked, it will start supplying the energy to the grid, or it will start supplying the energy to the given uh, industries or any storehouse or a warehouse, so it can supply the energy. So like that, mobile PV systems are also we can plan, or using the PV cells on fabrics or some large surface building areas or at the top of building areas or the south facing building walls. On that also we can have the PV cell systems. Coming to the wasteland, you can go for the deserts or any mining lands, or also you can focus on the surface of the sea water. On that also we can plant this solar system, or also you can think of some dam water which is stagnant for long time. So on that also we can plan for the solar PV systems, but that will be costly initially. But compared to purchasing the land and making it proper conditions for the solar PV systems, so that will all cost very high amount initially. So initially, to reduce the cost of plantation itself, we can go for the wastelands, large buildings, of the mobile PV systems using the vehicles that can be planned. Nowadays, even agri-voltaics also coming into picture. The new topic is agri-voltaics, where in agricultural land itself, okay, with minimum area for the solar radiation for the plants and maximum area of the agricultural land is can be covered with these PV systems, where the land is used for power generation as well as our agriculture production also. Okay, any points you want to add with respect to cost reduction in solar systems or solar plants? It may be cost reduction with respect to the site purchase or the planting the PV systems, or it may be depending upon the usage, okay, or it may be production of the PV cells itself, or it may be concerned with the low cost batteries and inverters. So in that all fields you can think of, and you can make many points on these cost reduction factors, which are especially helpful for us to understand and to implement these PV systems in the coming generations. So recall any of your points you want to add here, you can add here. You can unmute the mic. You can explain your viewpoints. So no points to be added. Now we'll take one simple problem just to understand some calculation. This is not for syllabus, just I'm taking for a example. As an example, I'm taking. Okay, is the screen is visible? The problem is visible to all? Yes, any one reply at least. Okay, thank you. Javed Ahmad Makandar, thank you very much. Okay, take this problem. In this, they have given considering solar radiation of 200 joules per meter square. So per meter square, solar radiation is falling with 200 joules, and per unit time during daylight. So always solar radiation happens in daylight, not in the night. Find the area of PV cells needed to generate enough electric power to run. What all things we need to run. So for that, how many PV cells are needed? That we need to find out. So one is a desktop or a computer using 400 watts. Okay, an electric geyser using 1 kilowatt, and a toaster using 500 watts. So these are the three devices. So based on three separate devices, we can find out what is the number of PV cells required, or else also we can find out the total number of PV cells required to run these three devices. Assume the efficiency of the PV is to be PV cell is 25%. What is given here? The solar radiation available per unit per meter square area. Per unit area they have given 200 joules. Out of this total energy available from the sun, efficiency of the PV cell is only 25%. Okay. So from this one can find out what is the power with respect to this efficiency, what is the power available from the one cell. Then we can find out for 400 watt what is the number of cells required, for 1 kilowatt how much cells are required, and for 500 watt how many cells are required. So like this you can also find out for a given module. Say for example, I will tell in a module there may be 15 cells. So like this how many modules can also be required, that it can also be taken. So here they are asking only number of cells. They are not focusing on the modules or arrays. We will find out only the number of cells. So efficiency, if you find out efficiency of the PV cell, we know that output power by input power. So for any machine or any efficiency formula if you write, it is nothing but output by input power. So power output we need to find out. Efficiency is given. Then solar power is the input power here. How much is the input power? Input power is 200 joules per meter square. So keeping this in mind, if you find out the power output by multiplying this 0.25 of the percentage, directly you can get the what is the energy supplied by these PV cells. That is coming around 50 watts. Okay, one cell is giving around 50 watts. Now for 400 watts, how many cells we can go? A simple example. You can take the ratio of 400 by one cell, 400 watt by 50. So area of the PV cell required is 8 meter square, or else number of same cells required is 8. Okay, so per unit area they have taken 25%. So you can assume 1 meter square is the area of the PV cell. It may not be 1 meter square only, but you can assume one cell. So similarly here 8 cells are required, or total area of the PV cell also, if you recall, we need 8 meter square of PV cells. Similar case for the geyser. So for the electric geyser, if you see, or the water heater, if you see, 1000 watt of the 1 kilowatt power is required to run. So by 50 watt cell or 50 watt power, how many cells are required, or how many number of cells are required per meter square? If you find out, that will be around 20 meter square. 20 meter square area of cell is required to run the electrical geyser. So similarly, find for the toaster also for 500 watt is half 10 meter square. So like this, if you add all the required devices or the machines to run in a home or industry, then total load what is available is you can find out by totaling all the load, and total area also required or total number of cells also required you can find out, and you can take the value. So as per these values, I need 38 meter square area of the cells to be planted to get 1900 watts. So this you can convert into number of cells or number of modules, how much you want to decide. According to that, later I can tell how many modules are required to run this total load. Okay. So this is one of the type of example just to understand how they calculate number of cells, the total area required to plant the PV system, and what is the total load to be run in the homes or commercial applications. So next problem you can just see here to find the efficiency of a PV cell. A heterojunction solar cell of active, it is nothing but PN junction. PN junction solar cell of active area 6 meter square. So area of the PV cell is 6 centimeter square. Gave the following results. So those results are open circuit voltage 400 millivolt, short circuit current 200 milliampere, under an insulation equal to 0.8 sun. Okay, this is not equal to 1000 watt per meter square. It is only 0.8 of sun. It is not equal to 1 sun also. So 1 sun, if it is there, we are always assuming for 1 sun, the radiations falling on the earth is 1000 watt per meter square. So in this 0.8 number of sun, how much is the insolation of the solar radiation falling on the earth, we need to find out. Then we need to find out what is the energy conversion efficiency of the device or the PV cell. Assume fill factor 80%. So these all things are given. Now we will go back to the finding the fill factor or the efficiency of the PV cell. How we have found out the efficiency or the fill factor of the solar system. So recalling back the earlier equations in our discussion, yes, here fill factor is given in the problem. Okay, so fill factor is given by the equation as maximum power point voltage and current product to open circuit voltage multiplied by short circuit current. So if you take these two products and ratios, one can find out the fill factor. And in the problem, they have given the solar total insolation from the sun for 0.8. Open circuit voltage is also given, and short circuit current is given, not insolation. Then maximum point voltage and current also you can find out. Then efficiency of the PV cell, if you find out, is again output by input. Okay, so here what you can do is input power, you can take the solar energy. Input power is the solar energy for this P0, and voltage and current, the product you can find from this fill factor equation. VMPP and IMPP, you can find out maximum voltage and current, and in this step we can find the efficiency. So like that, what they have done in the problem is the fill factor is given by maximum voltage, maximum current divided by open circuit voltage and short circuit current. So here to find out this maximum power output of the device, that is V into I at maximum point, we have taken 400 millivolt open circuit voltage into short circuit current 200 milliamperes. Okay, so they have taken amperes, into fill factor. So fill factor in the problem given is 80%. So just if you multiply all these three terms, you can write the answer is in 64 milliwatts. So all of you check this 200 milliampere, whether you have to take it in 200 or 0.2 to get this 64 milliwatt. Okay, this is the maximum power what is available from the given PV cell. So one cell is given here of area 6 centimeter square. Now next is, once you find out the maximum voltage and current, that is nothing but maximum power. The maximum power available from the device is known. Now we can find out efficiency of the given PV cell. So for that we need total solar radiation falling on the surface. So for 6 centimeter square, we have found out how much is the solar radiation falling. So you can recall again 1000 watt per meter square. So convert that into 80 milliwatt per centimeter square, because here 64 milliwatt is also there. So we need this solar radiation falling on the surface of 6 meter square. Okay, for 6 meter square. So we are multiplying this answer to 6 centimeter square. If you don't multiply by 6, then it will be for 1 centimeter square. So like that, if you convert 1000 watt per meter square in this factor, it will be around 80 milliwatt per centimeter square for 0.8 sun or 0.8 times the sun. Then if you multiply for a given area 6 centimeter square, I will get the total radiation falling on that 6 centimeter square area, that is 480 milliwatt. 480 milliwatt is falling on the PV cell, the total sunlight falling on the PV cell. Now we know what is the maximum power output of the PV cell, 64 milliwatt. What is the total power supplied to the PV cell, 480 milliwatt. Now we can take the ratio and we can tell the efficiency. So the efficiency is coming around only 13.33%. So like this efficiency can be found out if you know the voltage and current of the fill factor details. The steps are clear to all. So these all formulas we have taken again what we discussed in the theory only. Fill factor formula we know. Then efficiency also we know that maximum power by input power, or the maximum output power by input power, that is solar radiation. So from this we took the formula and we substituted all the values given in the question. Okay, next, like this, some other problems also I have taken briefly. You can just refer it. So as per our syllabus, if you see in our solar energy, for this solar photovoltaic system, here current voltage characteristics, cost reduction factors, applications of the solar photovoltaic systems. So nowhere in this chapter numericals is not mentioned, but to keep in mind why these equations, how they are helpful, I have taken few examples. Okay. And self-study is again application. Study on generation of solar power for rural electrification. and other necessities. So this is again applications of solar PV system we have to discuss. So in this problem also they are finding number of cells required. An application requires 300 watts. Okay, here 9.3 example and 9.4 both you have to solve in combination. Okay, you can take these 9.3 and 9.4 solved problems as homework. You just go through the steps and in theory what we discussed, you recall the equations. Okay, so we'll come to know the importance of that equations, where these equations are helpful to solve the problems in real time or in theoretical applications, so one can understand. Okay, so this completes the third module, PV systems, and preferably after IA we'll start with module 4. Okay, so I'll share that file with you. PV cell. Okay, the numericals I have shared in the group in the classroom. You can refer them later. Can I brief? Can you brief the portion of for IA? Portion for IA already told. From last week I am discussing the syllabus of IA only. The syllabus for IA test is for the solar system is unit 1 full with these solar measuring devices, then solar radiation geometry. Solar radiation geometry is here, unit 2 half. In unit 1, solar radiation outside the Earth's atmosphere, inside the Earth's atmosphere, that you have to discuss. Energy source, renewable energy source, some more we can discuss. Here, potential of renewable energy achievements in India. So this is like a general topic. Okay, that we already took as a course activity. So that reports all you have submitted and some have left. So that will take care later. So this is one general topic. Then we have general characteristics of solar energy, sun and solar spectrum, that also we have discussed. So unit 1, it is full. This you can skip, some part you can skip here. But importance of renewable, non-renewable resources, other things you have to remember. In unit 2, we are keeping only this part, solar radiation geometry. Okay, solar radiation geometry. Anything told about this topic? So in solar radiation geometry, you have to do all the angles with respect to sun and horizontal surface and the tilted surface. With that angles, numericals and flux. And for this subject, you have to recall all the equations properly, and the importance is more given for the problems, not for the theory. Okay, in this solar geometry, theory will be less, numericals will be more. Just a minute. Kashinath Gaudar. Kashinath Gaudar, just can you unmute? Yeah, already these topics are available in detail with all recorded lectures. Whenever you are free, you can refer those lectures and you can understand the things. Okay. All the things are discussed in detail. It's not required to repeat those topics briefly. Briefly, no, will not help, because the problems are very big, equations are very big. You cannot explain it brief. You can refer the old lectures I have shared already. And PPT is also more than enough to understand the details. And yesterday I have shared the solar geometry chapter and flat plate collector. From that, the full Sukhatme book is also shared, but that is uh, much is not there in for the first time. So just a minute, I'll just confirm whether the unit 2 is full or half. Yes, unit 2 is only up to here. Okay, the syllabus for first IA is unit 1 full, unit 2 solar radiation geometry full, up to here, solar radiation geometry. Solar thermal radiation devices and storage devices, and PV systems will keep it for second IA. Okay. The syllabus is clear to everyone.
Sir, sir,
Yes.
sir, your notes is enough, no, sir, for preparation for IELTS.
That's what I'm telling you. Refer the PPT. First IA PPT, like I have made according to the syllabus required for first IA. According to that PPT,
So that is enough, no, sir.
That is enough, but details where you study. PPT I have shown only equation. Details of equation you have to refer to book.
Okay, sir.
If I tell this equation in detail, all the parameters you explain. If I tell, you can write equation, but explanation of that equation is required. In such case, you can refer the book with PPT. And problem
Okay, sir.
problem file also I have shared. Similar type of problems will be there. Okay, same type of problems.
Okay,
That
sir.
problem file, PPT, and even brief notes about the energy resources, that also I have shared. Okay. So for the test, whatever is required, I have shared in the classroom. So please refer the classroom details. And yesterday also I have sent one chapter scanned copy of book. That is also important. Okay.
Okay, sir. Thank you.
Okay. I think we'll stop at this point. It is already 4:15. We'll continue on Friday. Okay.